So this is our last lecture for the HTML CSS course, and what we're going to do today is look at HTML5 as promised. This lecture is number 14, I believe, out on the bhacker.com website. I added it last night, so it's just arrived. It is based on this book right here, and the book is a guide to or essentials for HTML5, and it's going to skip over a lot of the easy stuff and just show you some advanced stuff in terms of the graphic capabilities. And also in terms of using multimedia, things like that. So I'm not going to go through and show you all of the tags and things associated with it. Instead, what I'm going to do is show you and orient you to what the new features are. And show you this book here, which is actually not too bad, actually, Guide to HTML5. Uses games, learning HTML5, and also JavaScript at the same time. So here's the, I should have put the ISBN in here, but I didn't. But if you download the lecture and just Google this name here, probably a more current version of it as well. Although HTML5 has been out for a while, I'm not sure if this book has been revised or not. So games to learn, basically learning HTML5 and JavaScript using games, or not really games, but they're kind of GUI approaches. So. What are we looking at? HTML5 is the latest, soon to be the version of, well, HTML that's going to be the standard. Not really, not yet. It's still HTML4. 5 is not supported by every single browser out there, which is what the problem with 5 is. So if you do something with 5, make sure that you're going to do it in a limited environment that's going to work in a browser, and you're going to specify the browser. Not quite the standard yet. So hopefully within the next few years, I know it's been out for a couple years already, so hopefully maybe another couple more years, everybody will be up to speed on it. Who knows? But that's one of the things you do run into. It is nothing more than text with tags for content. So the only thing that got added to it was content. So it's all of the HTML4, everything you know so far, plus content tags. So what are those? That's what we're going to basically look at. Just briefly look at it. And then I'll show you some examples where you can find the source code and you can find the examples themselves that I'm going to go over in this book right here. So this will help you kind of figure out where to hopefully find some information to explore a little bit further. So JavaScript also works with the particular HTML5, of course, scripting programming languages for interactivity, dynamic presentation. Cascading style sheets and formatting also work with HTML. Same thing as before, but we have a CSS 3 standard, which is slightly different than the 2 standard, but it's definitely an improved version to support some of the styling that goes along with HTML5. New elements, or new items, or new tags, I should say. Many new features for the support of semantic web, dynamic interactive websites. That's what we're looking at. Which is kind of different. In fact, there's a lot of controversy over this because HTML is supposed to be a markup language. It's not supposed to give you dynamic behavior or programming capabilities. It's just for the user interface. I mean, it's just for the look and feel. It's a markup language. So why add features for semantic web, dynamic, interactive website interactions, behaviors, which is kind of different. You're putting them in a markup, so you can still click on them. You can still click on buttons and things in HTML5. But anyway, long story short, it's crossing the borders a little bit in terms of what it was originally designed for. So caution, definition not official. None of the definitions of any of the tags are official, actually, which is interesting. And the browser support is evolving, but it's not 100%. And if you design everything in HTML5, you're going to have nightmares and you're going to have problems. So everyone is using HTML4 with limitations of some of the things that can't be accomplished. That, as an example, some of the embedded links for, let's say, for example, YouTube videos, a lot easier to do in HTML5 than it is in HTML4. Unfortunately, though, it's not going to look the same in 90% of your browsers. So HTML5, we still have problems with that because it doesn't look the same maybe in 40% of the browsers. Now you have, compound that problem a little bit further, essentially, and then restrict your users to only use one browser, test with that one browser, which in the real world, is that really feasible? If you're building something for a mobile device, only has one browser option, you're set. So it is becoming a reality, essentially, that browsers are different. So here's the new features. Semantic elements. What are the semantic elements? So we have the header, the footer. Headers and footers. Well, instead of just the head section, we have the header kind of concept, the footer concept. Sections, articles, So we have different body pieces or different components in terms of the semantic elements. We have the canvas for drawing. We can actually put dots and stuff out there. Paths for rectangles, arcs, lines, images, mouse events, and things. Local storage, variation of cookies. So remember cookies, and then HTML4 kind of worked with a cookie concept. No more cookies. People don't like cookies. Not good. So HTML5 has sort of a different approach to it, but it's storing the cookies on a server, not on a client. So there's limitations for the local storage, and it depends, and I'll go through that in a few minutes. This is just an overview at this point. Variations on the concept, kind of like a cookie, but not really a cookie. So we'll go to that. Audio and video elements, including drawing video on canvas. This is what HTML5 is very popular for right now. It's the audio and the video, because most people want to put audio and video components in their websites. So this tutorial is actually from the book. This lecture set is based on the book, actually, and it is what I'm sort of recommending. It's not expensive, but if you want, go ahead and venture out, search on HTML5 books, and if you learn by example, the best way to do it is just get familiar with something that you liked to work with. So what I'm going to go over today is the drawing elements. So building drawings, drawing triangles, rectangles, lines on the canvas, and the canvas concept, which is different than, now we're thinking, is this really HTML? Is this really mocking up text? We have a canvas now, and the canvas, we can put dots on the canvas, and we can put text in there with it, with the dots and the lines and the drawing capabilities, and it's real low level. It's actually not even that user friendly. So don't know how many people are going to use it for that, and I don't know if it's being used a lot right now. I know that there's other features that are probably being used a little bit more. Building, and there's an example here for a coin toss. Flipping a coin, and having two images. You can actually do this in HTML5 without, well, with some JavaScript, but so handling events, so event handling, drawing text and images on the canvas, and then finding video clips and then converting them, and I'll show you a little utility that's actually free. That's not too bad for converting the video, because what ends up happening is we have, lo and behold, another problem that HTML5 comes into. It'll look nice in one browser. The tag might work. You load it into another browser. It looks nice. The tag still works. But the video content's not supported by the browser. So then you have to convert it. So on the website you have to check to see, well, what browser are we using? And then what video file are we going to put along with it? Kind of thing, what format. So adding the video to favorite sites and make it a standalone kind of, sort of. So balancing video, drawing video, creating masked, timed events. Building geolocation application and including Google Maps API and Google Storage, local storage. Easy, actually. You can build in with HTML5 the Google mapping capabilities. So you can put those lovely little things I'm sure you've seen all over the place. It says, get here, give me directions. And it shows you a map, and it kind of builds it. It looks like Google Maps is Google Maps, essentially, integrated in. Nothing more than creating a tag for it and putting it in. I'll show you examples of that. And then previewing some of the essential guides to HTML5 in terms of content. The template, if you remember, looks the same, acts the same. It is HTML5. You should be familiar with this. We got the head, we got the body, we got the HTML, opening and closing tags. Language is English. Document type HTML5. A little bit simpler, actually. You don't have to go as into detail in terms of all of the different support for the metadata for the document type stuff. So that's what we're looking at there. So what do we have here? I'm going to see if this link actually works. I'm going to click on this link here. See if the link actually brings something up here. Making sure tutorial spot, HTML5, HTML color names. It does bring it up. That's very good. Okay, good. So that link works. So canvas element. So along with the text, we have this canvas concept that's introduced with HTML5. So you use code to define so-called content. Methods of the objects, methods of this object do the work. So we're creating objects that are going to appear. And then we have the screen geometry. So we have the upper left-hand corner, which is the origin, and the colors are defined by the red blue and green color scale. If you click on the link, which I just tried a few minutes ago, it does work, and it takes you to the number system that's associated with the color scale, so you can put those numbers in. In fact, you can use those numbers, actually, RGB scale, for any color that you're defining in HTML4 as well. Stroke versus a fill, and then we can draw rectangles and shapes and things. So what we're looking at here is the canvas definition in terms of some points on the canvas. We have a hollow rectangle, black one, one that's filled in with a color, green one over here. And we have the coordinate system. So there's actually another couple of utilities out there that can allow you to move your mouse around, and it usually shows up in the status bar or something on the bottom where it just gives you the coordinate system for the location. So this is what you can do. Actually, just draw stuff out there. What are you going to draw? Well, it depends on what you're trying to use this for. And what we're going to do here, then we're going to have this variable, and the variable here, and this is looking like document element at canvas. So get content 2D. So we're using the document object kind of modeling as well here. And we have a function in it for initializing. This is the complete document. Actually, if you take and cut and paste this and put it into a text file, I believe it is one page only. Yes, it is. It will actually work for you. It puts 4 rectangles. What does it do? It does this. It does 1, 2, 3, 4. Cut and paste it. And actually, this is a good way to see if your HTML5 is going to work. Because on the bottom, it's going to say, your browser doesn't support the HTML5 element canvas. Because we're using a new element called canvas. And if you cut and paste this is slide number 9, save it as a text file, and double click on it, open it up, put it in your browser, you can immediately tell if you're HTML5 compatible at this point. I would try it in Chrome. You probably are making it just fine. Chrome is pretty compatible. Firefox probably not going to, I don't know if it's going to work or not. It might be a good test to find out. But we have a new element, it's called the canvas. And what is this canvas? Here it is here, a canvas. Well, what is the canvas? The canvas is this background canvas. It's the region that we've defined that we're going to draw on. So we can't do this in HTML4. There's no such thing as a canvas. And there's no such thing as drawing. We just put text out there and we format the text, essentially. So this is a script that we're going to start out with. That we're going to have a variable for the center for CTX. We're going to have a function to initialize it. It's going to be equal to, CTX is going to be equal to, we'll get, this is not JavaScript, by the way. We're going to get, let's see, this document, we're going to have it equal to 2, we're going to fill it in, and here we're going to end the script. And on the load, body on load, we're going to run init, which is the function. So we're recognizing this function and we're going to run it in to look at this document element canvas that we're going to create this, we're going to assign this element to this object CT, and we're going to say the line width is going to be equal to 2, the stroke is going to be equal to this, the fill is going to be equal to that. Basically using the graphic components of the object that we've created, the instance of the object that we've created of a canvas type, that's going to be a 2D object that's going to be assigned to CTX in this particular example. And we're running the methods to change everything, which is great. What are you going to use it for? I don't know. You can draw lovely pictures now. So you can, probably comes in handy. But it's also a good test. So run it, you'll see if you get this message on the bottom, it means no canvas, no canvas, no HTML support, HTML5 support. JavaScript is a scripting language interpreted by statements, and I don't mean to lead you wrong. This is a script. This is JavaScript, but it's not mentioned as actually. If you take a look at this, actually works just as a script. It's built in and integrated completely. So we don't have to worry about JavaScript, Python script, this a script, that the script. We just say script, and it's assumed that we're going to run it with the scripting language. By default, it's JavaScript. It's going to run from HTML5. So. Not compiled, no error messages, semantic errors. So what we're looking at, just one more comment on the JavaScript concept. It's kind of assumed at this point that your HTML is going to work with JavaScript, and then they're one and the same in terms of the script is what I meant to say. So it is a script. Don't want to lead you wrong, but it's not explicitly defined as JavaScript. It's just assumed. So okay, so no compile time, not compiled with error messages. So semantic errors might exist. Errors of meaning are more difficult to detect and fix. Obviously, semantic errors are errors of the form, and I'll go to grammatical errors. So Firefox tools, we have an error console that can help. Most common, bad bracketing. This might be a problem filling in the attribute not mentioned or something. So it's just a little note on errors. And your HTML5 browsers are giving you, or compatible browsers are giving you more error checking because there's more scripting being used with it. So you're going to get, and this is just an example of the error console that ends up with Firefox. It's going to show you that the sctx.fillStyle is not a function because there's no function called fillStyle, which you're not going to get in previous browser support because they're not going to go to this level of detail. So we have a little bit better error control, error checking with HTML5, especially being used with scripting languages through the browser. It's the browser support that's offering you this. But the browser has to be updated, so it supports this. So not all your browsers, unless it's going to be HTML5 compatible, is actually going to take this next step. Because if you think about the concept here, if we have this new variable type that we're using, and it's CTX in this example, which is a canvas, and we're running a method on this canvas, and the canvas is an element of HTML5. It's not an element of JavaScript or any other scripting language. Then we need to be able to figure out if the method is correct, if the object is correct. Do we have support for this? So the level of error control is actually kind of important in terms of that concept. So the drawing is done with an init function, which is called when the body element is loaded. So we've got this init function down here on the bottom. It's just regular onload. And you could do this with anything, actually. You could do this in HTML4. So onload, run the init. And the canvas element with the ID is equal to canvas does not exist until the body is actually loaded. And the default color is black. Red, green, and blue values are ranged from 0 to 255, 8 bits of intensity. And you can see that from the charts from the link in the previous slide. And stroke style and fill style are attributes, not methods. They're attributes that are associated with it. And to go, they experiment with colors by name and GRB. Note that the quotation marks are in there, and the location and the width and the height are also set. So you can see in the code here. With the line width is equal to 2, the line stroke, the fill rectangle. These are all attributes that are being set. And here the stroke style green. So we can use the RGB colors or we can use the built-in colors. And apparently there are more built-in colors with HTML5 as there are with HTML4. Nobody really memorizes the colors, but sometimes, you know, actually there's navy, there's maroon, there's orange, you know, basic colors. But apparently there's more. There's some added to it, but I wouldn't know which ones were new and which ones were old. I always have to kind of look it up to see what it is when I want to use it. So here's some more comments on it. Drawings are painted on canvas. So the rectangles are not objects to be moved or referenced later. They're painted on a canvas. The only thing you can really touch is the canvas. So the canvas is what you're going to show, don't show, move. So it's kind of a whole unit. So using CTX, which is the name of the object of the canvas type that we created, clear rectangle method will erase it. So clear rect method to erase. Need to do calculations to detect the hits. So to know what you're going to erase. And then alternate is dynamic placement of HTML markup in the canvas as well. So here's another drawing, and what I'm going to do is this. I'm not going to go, you know, like run this stuff, but you guys can run it on your own, actually. But it's actually pretty easy code, and the examples are pretty simple. But here's another example. It's a little bit more sophisticated. The paths are created with arcs and lines. So we just put basically 4 rectangles in the 4 corners of a screen. So the arcs now are portions of circles, so we can create the arcs by expanding a little bit, creating or using radians in the place of degrees. So we have the math.pi is available, and complete the circle can be drawn basically using the math functionality for it, and the arc can be stroke or filled. So here's an example of drawing an arc with angles, and so we can fill it together. True means a counterclockwise drawing, so we can have, you know, different degrees and create actually more elaborate kind of shapes with this. So CTX arc, ARC is what we're using for this, and which is another attribute of the canvas element that we're using. X is the center, Y is the center radius, starting angle, finishing angle, and true for counterclockwise, which means we're doing it what direction. True or false is going to be counter or not, or clockwise or counterclockwise, depending upon what we want to do. Why do you want to do that? Well, if you have a slow moving screen, you might want it to paint in a certain direction, perhaps. A slow loading screen or something. No drawing or ink at the center. This is important when connecting arcs and lines. It's experimental. It's an experimental feature, so it's not a bad idea to experiment with different ways of doing it to see how you're going to be able to make complex shapes with this. If you really want to get into the graphic components, here's an example of a complex, very, very complex shape. A little smiley face. So this is the window. And in the window we have this little smiley face. What does this come in handy for? Well, there's a special character. You don't want to use the ASCII code equivalent to it. You want to put your symbol, you want to put your logo in there. You can actually create the logo in HTML5, put it on a canvas, load the canvas into your website, and then it's kind of unique in itself. It's not an image, so it's going to load faster. And why do we care about that? Well, huge images on mobile devices and stuff take too long to load. So now we can create more dynamic and more interesting looking behavior graphically, manually, but graphically, to save time and energy, to make it load faster, give you some trademark symbols and stuff that might be good. So 4 distinct paths. Each path is made up of 1 arc. So the default is red and brown, essentially. So we get this kind of combination. So a strategy being used here to use variables with some variable values defined in terms of others. And then the circle face and the 2 eyes, or smile, is partial arc. Here we have a little partial instead of doing the whole arc of the circle here. And the brown eyes and the red smile. I don't know if those eyes are really brown on your screen. They're not on mine. And the red smile. So the body element is the same as before. So you can add the code for this to your rectangle drawing. And if we were going to add the code to the previous example we just looked at, here would be the code for it, where we have variables that are going to be defined in terms of other variables, which is interesting. So we're using variable CTX, which is our same guy as before. It's going to be our canvas. And then we have the head X, the Y, head Y, the head radius of the face, and we're going to define all this stuff out, and then we're going to put all this stuff inside our function init so that we can actually draw it along with the other 4 triangles, or 4, squares that we were drawing before. And if we add the code in, and we're going to say this is the brown CTX fillet here, and the arc's going to be the head X plus the left eye offset. So we're putting it all together in combination and building sort of a tree out of it. And don't have the final version of it here, but the circle with the smiley face ends up in the middle of the 4 if you put it all together. And you just cut and paste that code and it actually works for you. It will put the smiley face in the middle of your four corners that have the squares in it. So some comments on this. The fill in the stroke calls close the path, so we fill it and it fills in the circle, or it fills in the strokes, which completes the line from point to point. Also, you can close the path with a close path method, so you can call a close path method on it. It says draw in a certain direction and then close the path. Go to the beginning or the ending point of the previous point. So using variables makes code more flexible as well and easier to see relationships. And then for the go, draw the arcs, changing colors and sizes, etc. You can experiment with that in terms of being able to modify it. And a little note on the bottom, you can draw non-circular ovals using transformations or scales. And check out the hangman game. There's a hangman game actually in the book that actually has you draw on a canvas, hangman components. So, which is kind of interesting. Actually, the hangman game is not too bad. So there's not really games, they're drawing games. And I can't remember. Oh yeah, the hangman, I guess you fill in. You can actually do a really nice hangman, which is actually a rare example, I think, of a game that uses text and it also uses drawing in HTML. So next drawing is going to be a star shape. So after drawing the lines and arcs, think of moving a pencil versus drawing. Preparing to draw a line segment. So the one before was using arcs, and arcs is a parameter that you can do on the canvas to create an arc, which is going to be a circle, a half circle. You can also draw lines, connect lines together, and create a star. So there's all these examples actually are in this book, but the boy, loud hallway today. So the lines, nothing is drawn until the stroke is actually filled. So you use an array with coordinates of 5 points, and use an array to hold names of 3 colors, and then we have a button element we're going to put on here too. So the opening screen looks like this. We put a button on the bottom. It says make a star. This is our blank page. It's going to be a crude star that's going to be created. So after the first press of the button, we get the star with the red, and after the second press, we're going to get the open, and we'll look at the code in a few minutes with the no red. So red, no red, take the red out. Blue, change it, make it blue. Why do we want to do this? Well, this is not 3 different images, it's just 3 different canvas changes that we're doing. It's easy, actually. So we can make a status. So example, we're loading a page. It doesn't have to be a star, it could be like a bar as an example that moves. You know, we just fill it in. We fill it in further and further with progress. That's in our code that's doing some loading or doing some stuff. Or, I don't know, maybe some rating system that we're going to do on a website where we want to put in, you know, given a certain number that someone's put in, it's going to fill in the number of stars, or maybe they fill in the GUI because it's clickable, fill it in to a certain point, and then take that calculation and use it for something mathematically or something. So that's just an example. So here we're going to do is show the body first. So this is the first page we looked at with just this, with the button. It says make star. This should hopefully look a little familiar to you. And then at here we're going to say canvas. ID canvas, give it an ID so we can call it. The width is 60 and the height is 40. And then we're going to say your browser doesn't support HTML element canvas if the canvas doesn't get created, because the canvas isn't going to show. So the first thing we're going to do is create the canvas. It's the same thing we did in the other example, but it's a little bit easier to see it because there's no code. There's no other code in here. So this is not a bad page either, just to cut and paste this, stick it in the browser, and see if it works. So if you can't create the canvas, you can't use HTML5. You know you have HTML5 when you have that canvas. So if you don't see these words, it means the canvas covered them up because we're putting the element in there. It's just the same way as we can paint video. When we put the video in, if the video doesn't show, it's going to be blank. And underneath it, we can say it doesn't support HTML5. Okay. Or if that happens, put something else in here so the canvas fails, but another embedded link works or something. So we can kind of makeshift it. And then we have the button on click down here. We're going to put a button here, make star button. Make star is the title that we're going to put on the button, the caption, and we're going to close the button tag. And we close the body and close HTML. We didn't put the top part in here, but it doesn't really matter. The top part is just going to have an opening tag for HTML. So now we create the variables in the script element. So here we have variable CTX, same as before. And then we're going to have an array of points, so 5 points for the star. Rough drawing here. We have 1, 2, 3, 4, 5. And then we'll have the colors red, white, and blue. And used in succession, we have the variable C, or the counter. It's going to be equal to 0. Points to the next color. 0, 1, 2, 3. Depends on the number of colors. And then 5 points of the star that are going to be drawn here are going to look like 1, 1, 2, to kind of illustrate the point with the colors. So this is the same code as before, but it's just showing you the lines that are being drawn for the points. So that would be 3, 4, 5. So we can draw the star. Kind of like drawing it with a pen, actually. Which is kind of similar. So the points now here, we look at the bottom and we can fill the star in. And if we look at the init method here, we can reduce one line using colors. Kind of a C++ syntax here, where we get the C is equal to C is less than 3, then check to see if C is set C at 0 as an initial starting point, and then go through 0 through 3 and move the points around. So And then a fill it's necessary for the white star, actually, because it will fill it blank, because there's no fill color that's specified in this example. So we've got essentially these being drawn using the definitions. So we have the red, white, the blue that are being filled in with the lines. So we're just basically creating an array. So this is why you kind of want to look at arrays in terms of the points. So we put the points in an array, we draw each item in the array, which is going to be each point. When we fill it, it fills the line from point A to point B. So there's no line. You're just putting points out there and filling it. It's the same thing we do with the rectangles, actually. We put 4 points out and filled it. Which is kind of different. You don't have to actually draw the line. You're just filling it. So move line to point, point, point. Okay, so now we can create some more fancier lines if we want. So the code to draw stars is more precisely. So position each star randomly on the canvas. So add a star with each new button that's pressed. So increases the number of colors. And I believe this one is going to be our color tutorial as well. This is the same link as we had before, actually. That's going to give you the RGB colors. So you can improve the coding for more robustness. And here's your stars. Randomly going to put some stars out there by using the same technique as before, the same stars. Actually, you can change the sizes of the stars by using a random variable as well. It's kind of like the dice rolling game, you know, randomly selecting 1 through 6 or whatever. So the strategy here is to reuse the code for the making the star with modifications. So remove the clear rec method. We had a clear rec method after the code here to clear it out. Clear rec, here it is, clear it out at the beginning, because after we made each new star, we painted the white one, we painted the red one. Well, we cleared the canvas essentially. And this is going to clear the canvas for us, because it's a rectangular canvas that we're creating in these examples here. 2D canvases, I should say. So if we clear the canvas, we get 1 star at a time. If we don't clear the canvas, we get all the stars put in there. We just change the positions around. So you put a random number in to change the positions, put a random number in there to change the colors. You have a very small amount of code that just puts a star out there, but now it puts it out all over the place. So this is what it looks like. So remove the method add a call to build the star that recreates the points in the array. So you're going to essentially build a method to call the star painting over and over again. Add items to the color array, remove 3 from the code, position the size, rotation of the star using math.random. So it's the same thing we did before with the dice. So here's the variables here for colors: purple, yellow, teal. In terms of our points for our variables, and then we're going to build star. So the build star method is going to be added. We put the build star method in the make star. And the build star, we'll look at that in a few minutes. But here we have the color C is going to be equal to, we'll put this little kind of check in here to go through each one of the colors. And here's our build star method. Build star is going to use math.random to create the locations for the X and the Y. So at the X location, XY location here, XY location here, it's just going to randomly kind of select those things. So, which will give you kind of some interesting stars. So some comments on this, lessons in these examples is that drawing are dynamic. The drawing is dynamic. So instead of just putting a static picture out there, you can actually dynamically draw something with HTML5, which is different, has a purpose. Can be done under specific circumstances in the program and uses different values or variables as well. And do this if there is time. Consider changing names of colors, constants. Well, yeah, if you look at through the examples and you're interested in learning it a little bit further, experiment with drawing different types of shapes instead of stars or instead of rectangles. Draw something instead of or in addition to a star as well. And you'll see it's kind of primitive yet very user-friendly and functional in the end. So the other example is going to be a coin flip. So note that none of these examples I've shown you so far are using any images. Now we can integrate images we can immigrate them, images into the canvas as well and draw stuff around it or use something with it, or we can simply just display something. So a coin flip, a flip of a coin. So draw an image from an image file of the head or the tail on the canvas where the player clicks the mouse and it draws a head or a tail from the picture. So event handling, it listens for the mouse click, and then the draw image made from the external file. So the draw text with directions on the canvas, essentially. Which is different. So we're still using the canvas element that is part of the new feature that I'm talking about. But now we're using mouse clicks on the canvas to get mouse events, and we're also actually adding text and images to the canvas events instead of just drawing something on the canvas. So here's click on the canvas to flip a coin, and we've drawn that on the canvas element. And then here's the coin, and it's a head. And well, I don't have to show you. The tail's not even in here, but if you clicked it again, maybe it would go to a tail. Or maybe it's randomly selecting the image, so we don't know if it's going to be heads or tails. Might come in handy. Actually might make for a nice app. You're trying to decide, should I go or should I stay? Well, let's just flip a coin. Here we go. Randomly flips your coin for you. So the strategy in terms of the design of this is you need to locate or identify the file address for the images. So you can have them in the same folder, use relative addresses, or use a full URL, same as before in HTML4. And then we have the image objects with the source attribute that are being used, and the font set for the context. And the context is going to be the canvas that we created, the context. So event handling is done for the canvas element, not the context, but for the element in the canvas. And sets up a call to a function that has one parameter. So it does require browser-specific code to get the mouse coordinates. So using a mouse in the canvas is yet another problem because you're relying upon the browser to give you the proper coordinate system. And you may have noticed this already, actually. There's some web pages you load up, and depending upon your browser support, you click and it's slightly off, like about 2 inches or something. I mean, it's like on the same page, but you're clicking and you got to click way off the image in order for it to work. And it happens even with HTML4 code in terms of browser support. It's the browser that's giving you the canvas orientation. It's the browser that's giving you the coordinate system for the mouse. So how does it know you're clicking on the button? Well, you got to click to the left of the button or to the right of the button instead of on the button. That happens actually, and it's out on a lot of websites actually, which is kind of funny. It's the browser. So use techniques for checking for presence of attributes. What I do is I just make that window big. You clicked anywhere on the page and it clicked the button essentially, which is what a lot of people do too. If you've ever noticed, if there's a button, just don't even click on the button, just click around the button and it works. So, fonts are from what is available on the client computer as well. So if you're using fonts on the canvas that aren't supported, you're going to get whatever the browser, whatever's on the computer essentially, whatever's going to be capable. And draw the outline or the stroke rectangle to show the player where the canvas is. So if you don't put anything on the canvas is blank. How do you know you're supposed to click there? Which is kind of interesting, because people generally click where the words are. They'll click on the words. So in this previous example here, if we didn't click on the canvas, where's the canvas? We're not going to get a box that goes around the canvas like this. It's going to be the web page, which is the great part. So you can have text and then, put a canvas in here. Then on the canvas you have something. You can click on the canvas and you can pick up the canvas click events. You can click outside of the canvas and you can get on the regular HTML events that are happening. And you can have it all separated. You can put stuff inside of the canvas, take stuff out, integrate it seamlessly together. And the user doesn't know there's a canvas in there. So they have no idea, which is great. Or you could put a box around the canvas, put the canvas inside of another element. All this stuff can be nested, by the way, just like everything else in HTML, which is kind of interesting. So you can embed this stuff in here, and it actually comes out, makes for fairly interesting interaction. So alternatives to color names or RGB is hexadecimal, so you can use Photoshop or PaintShop Pro or something to come up with the hexadecimal numbers if you wanted to. And note that the code makes adjustments to put in the middle of an image where the mouse was clicked. So wherever the mouse was clicked, it picks up the coordinate, this code example I'm going to show you, and it puts the image in the middle, so it calculates the center of that coordinate system. So we have some variables that are defined in here. One of them is going to be variable canvas1, and then we have the context variable, and then we have the head, the tail, which is going to be new images that we're going to create. Head.source is going to be this, tail.source is going to be that, and we have the coin width and the coin height, which is going to be the little box area that the coin image is going to be displayed in. And then here's our init function. So the init function is going to be called by the body when the body the body loads. And we have our canvas, same code as before. In fact, this is the one good thing about this text and these code examples is they all follow the same pattern, which makes it kind of easy to learn, actually. Not to keep selling you this book, but one of the better ones I found, actually. I spent some time looking around, and there's so many books, and it's like HTML5, but it's all talking about HTML4. So why do you want to relearn HTML4? When all you want to know is what's new in 5. What are these new features that we're talking about? That's why I like this one, because it's like none of the old stuff, just the new stuff. So it's like, okay, good. Makes it easier to understand. All right, so we're getting the document element by ID canvas, and the canvas element is going to be added to CTX, which is going to be, and we have our other canvas. We have two canvas elements, canvas 1 in this context of the canvas. Canvas 1, we're going to add an event listener. This is a attribute that's being put on the canvas to listen for events. So we're going to add the event listener. It's going to be a click event, flip, false. So it's going to click on the canvas to flip a coin is going to be the fill text that's going to be put in. We're going to draw the rectangle for the area that we're going to essentially fill in with this background color, which I don't know what color that is. And then we're using italics, 20-point accent font. If the font doesn't exist, that's an interesting question. What happens? It's not going to be able to use that font. So it might actually not show any text at all, which might be interesting. So make sure to use, like, if you want it to show up a certain way, use common fonts that are available in the Windows system. This is the flip method that's being called. I believe the false means no return on here. Click is going to be what's going to be the event that's going to be captured. So we look at flip here. We take the environment that's coming through, which is going to be the coordinates, run flip. Flip is going to be, well, make an X, make a Y. Here, clear the canvas out. And then now we have, what is this for Firefox? We're going to do this. Else, do that. For Opera, do this. For Firefox, do that. So, depending upon what we're doing, we're going to take the XY coordinates because we don't know exactly where they clicked because we have two different definitions of the mouse coordinate system for both browsers. So we're going to be nice. We're going to adjust it for each one, which is what you're going to do. So the environment layer X, so here, offset it. So then we're going to randomly pick out, a number from the math object, run random. And then we're going to basically draw the image out there. And then we're going to put a little text here, fill the text in. So comments, you need to acquire 2 images to represent the 2 coin faces. Download to the same folder or use the exact complete address. Just put them in the same directory. And you can go into Word or equivalent to see the available fonts that are on your system. So there's more in the book and online, actually, in terms of examples that work with this concept. But this is not the complete. Is it the complete? I don't see. Oh, yeah, I do see the images being loaded. Okay, so drawing the image. So, which is our draw image. Now, see, our images is going to be our head and our tail. So, but in any case, you can kind of go through and, in fact, the examples themselves are already written for you online if you find this. And I should have put the URL in here, but if you find the URL for the book or if you find the address for it, you can find these examples as well. So outside of the canvas, we have multimedia support in HTML5. So background here on the audio and the video. So this is what most people are using it for. Well, let's just say most people. This is what it's easy to do. It's really easy to kind of add the audio video support. This is native support, no need for plugins. So HTML4 uses plugins. We have to load a plugin. We have to load the plugin into the browser. We've got to call the plugin and load the media file. A lot more work. So what they did in HTML5 is like, get rid of the plugins. No problem, because plugins aren't really supported on all browsers. But HTML5 is not supported on all browsers either. So it's like the chicken before the egg kind of concept. But anyway, long story short, no plugins. So it's dependent, no dependence on YouTube. So issues multiple formats, aka codexes, for each one of them. So you're going to have multiple different image file formats for multiple different platforms, for multiple different browsers, for multiple different purposes. Different browsers recognize different formats. Not everybody's the same. So situation may improve, may be standardized. That's a good question. It's been going on for a couple years already. I'm not quite sure it's going to be standardized within your lifetime. Maybe by HTML6 or 7, perhaps, but it's taken a long time to get to HTML5, so good news, the audio and the video elements provide a way to reference multiple files and let the browser choose which file it's going to load. Through the order does not seem to be important. Doesn't really matter in terms of speed or efficiency on the page load. So let's take a look at some examples here. Here's the audio and video element. So audio. So we have an element now called audio. It's just like Canvas. Now we have audio, and we have video, and we have an opening and closing tag for audio and video. So basically that's all we did. So audio is going to be an audio auto buffer, which is going to be one of our properties that we can set on here. The source is going to be a OGG file. The source is going to be a .mp3 file. The source is going to be a .something or other file. So you list out multiple sources. And what ends up happening is I would put the first one that you think is going to be most compatible up at the top. It doesn't really matter though which order you put them in. It's not supposed to be significantly slower or faster in any other order. And the order doesn't seem to matter for the browser. It's just the browser is going to be able to pick from the source which one is capable of being played. So you list out half a dozen sources. What does that mean? You have the same file recorded in 3 or 4 different formats, and you have it on the website in your directory, and you load it this way so that one of them is going to load. Probably the first one that matches the supports. But what's interesting is some browsers will load MP3s. Some browsers won't this way. So some of them are going the OGG route, or the WAV, or the whatever format you happen to be using. Video, same kind of concept. So we can put the controls, so to have a forward, a back button. Actually, you can put controls here on the audio to stop, to start, to rewind. So the video here, we have source file is going to be S-file, MP4. Here's an OGV. W, WebM, and then we list out the codexes that are supposed to be used for each one of them, along with file type information. So the VOBIS. So it's kind of like the images, but we have to specify out the codex. We specify out the codex, so you use this one, use this one, use this one. Same concept as before. Whichever one happens to work in the browser is going to be used, hopefully. So our goal now, find and download video files. So you find and you download a bunch of video files, use a microconverter to produce other formats. And I'll show you a free little program that actually is designed for this. Put the audio in one of the existing projects, put the video in one of the existing projects, build the audio bouncing, a little bouncing ball perhaps with the audio. Look at the books Rock, Paper, Scissor for playing specific sounds at specific times. Example. And then the book also has what's called a quiz example for keeping video invisible and playing it only when the quiz round completes. So, but you can actually have more control actually over the audio and the video playing. So to acquire the video, you can make your own. You can find it online. Here's a source for video repositories. Lets you specify out the URL and choose from the videos to download. I respect intellectual property, obviously respect personal property, friends, family, etc. So, which goes along with videos and also for audio. Produce formats for all browsers. Well, this link here actually works. It's microconverter. I believe it's a free program. Let's just see if it still works, which it does. Finally, a beautiful way to convert almost any video to MP4 and WebM, VP8 format. For Android, for iPhone, for iPad, all the different versions. So the link actually still works. I believe it is a free program, supported devices that it works on. So you may also find other converters out there as well. But the idea is if you're going to do this, you're going to end up having some sort of converter software because you need to put it in 5 different formats to make sure that the video actually shows, and then test it in each one of the browsers that you're going to use it in. So download the program. The original file, if you're going to load one as an example, might be in several different formats using Flash format. Used for YouTube is actually the Flash format. So follow the directions and should produce the 3 formats that you need for the example. So video, putting video element in your favorite sites or something else, or I don't know, using video along with a menuing system or something. In fact, now we see video embedded everywhere. You just click on it, it runs a video right there inside of the page. So test using Firefox, Chrome, and Safari, not bad. And patience, because sometimes the video just doesn't work, essentially. It just won't work. So when we get browser plugins, we get a stationary plugin that gets loaded where we say to load it. When we create the element in HTML, we can move the element all over the place because HTML5 is more dynamic and interactive. We have mouse events that can happen in a canvas. We have animation. Well, how do we get the animation? From the dynamic behavior that we can do because we can move the element. So there's an example in the book that moves the video. We have a bouncing video that happens. There's 2 versions of it. One moves around a video element. The other one uses a draw image to place the video on the canvas and then move it on the canvas. Works in Firefox. Doing this makes it easier to draw a mask, otherwise it's difficult to position it. And so it's easier to move it if it's stationed at some sort of, I don't know, some sort of a destination kind of thing where it's going to bounce or it's going to fly or it's going to do something, move left or right. Not quite ready for prime time. You need to put in code to wait until the video is all downloaded before this actually happens. So, which is kind of tricky. So sometimes the video doesn't download immediately, and if you start moving your animation, you're never going to see your animation, actually. So you can put a timer in there if you wanted to. So strategy in doing this is they use the set interval to invoke a my draw scene, which is going to be a function that we're going to do to draw the scene, and we're going to use some random interval that we're after a little bit of waiting period. So we can reposition the video essentially. So check against the virtual walls of the canvas and make sure you don't go off the canvas, and then apply the angle of the incident, which is going to be equal angle to the reflection. Pretty easy to do using the built-in methods and attributes for that. And use a stroke rectangle to draw the box. Note the loop attribute didn't work, so he set up in the book he set up a event handler for the video ended event. So some of the items might work, some of them you might have to tweak a little bit to get your video to bounce correctly. So in terms of the functions that are created in this example, we have the init as before, which is called on the onload in the body, same kind of format as before actually. Restart, which just adds an event listener in the init. We have the draw scene function. That's going to set the intervals in the init. So this is different in 2 different versions actually. And then move and check, which is going to be basically called the draw scene, which says, you know, did it move? Check it, then draw it again. And the bouncing video rectangle, we have a canvas and a video distinct elements. So we create the video element, as you saw in the previous example. We create the canvas element, and here it is here. Here's the video in motion, not moving because I don't have animation set up here. But what we're looking at is this video can move all over the screen if we want it to. And we've set the size of this from our video attributes. And we've set the size of the canvas, and we put a little box around the canvas in this example. So the style section. So positioning and layering, which is not necessarily a term used in standard HTML. And note to change the z-index by the JavaScript to using a z-index. So here's our style tag, same as before actually, it's the same style tag. In fact, it supports CSS as well. Where we have our video, are going to be our position as absolute, and our canvas position, which is going to be set to absolute, the z-index of 10, and here we have a z-index of 0, so which we're going to set for the style. And then we're going to include our JavaScript code that's going to bounce the video for us. And so we have the canvas width, the ball radius, actually, I'm sorry, this is for a bouncing ball, by the way, which is our bouncing canvas. It can be a ball. You can draw a circle, an arc in there and bounce a ball, or you can bounce a video. Same example, actually. We can create our X and our Y coordinate systems for our balls here. And then we have our function init that's going to be used to start and restart our active add event listener component, so we can listen for the changes. And then our restart method, it's going to be our current time and our running our play, essentially, to restart it. And our draw scene method, that's going to take and create essentially the ball item or the video item itself, and then run the move and check, which is going to be basically looking at, did it move? Yes. Then reposition it, and then run the init again. And basically, it's going to cycle through in a loop. It's kind of a makeshift loop, actually, that was created by calling one method and that calls another method that goes back and calls the original method. So, and then here's our move and check. Find the existing variable parameters, the X and the Y, and then check it against the get it from the canvas right now. Where is it right now? This is where it started from. This is where it is now. Compare the two. If they're equal, then move it. If not, then if they're not equal, move it. If they are equal, it hasn't been moved yet. If they aren't equal, it has been moved. And this one's going to play a file. It's going to play an MP4 file. It's going to loop through. So you'll have to figure out how you're going to get the music in here. If you actually do this example, cut and paste to put it into a text file, save it, run it, you'll have to make sure you have the image or the video file, which is the video that's playing the MP4. It's actually not audio, it's a video file. And we can tell by our video opening and sourcing. And so our source is going to be the name of the file with the codecs, type of codecs that's being used, given the name of the file and the extension. So the bouncing video circle works in Firefox, and the video is used in the image draw, and the mask is created, the box with a whole position over the videos to produce a circular kind of video. And so now instead of a box, we have a circle, so which is kind of interesting. I don't know, I actually really haven't seen too much of this done yet, but because most people, when you watch video, for some strange reason, it's always a rectangle. But what if you don't want a rectangle? Well, here's another example. You put it in a circle. If you're familiar with the tagging system, you can do this in HTML5. Can't really do this with a plugin. Plugin's not going to work. So, plugin is always going to give you a rectangle. I have seen some pretty sophisticated plugins, though, but it's always a rectangle for some reason. So this one creates an image view. And the image view, it's an image box, essentially. And the box happens to be an arc instead of a rectangle. Same code as before, by the way. So I'm going to kind of skip through it. Init element, draw string, it's the same code as before, except for we're drawing the scene now. We're going to draw it as a ball. So we create a rectangle, a circle using an arc on it. So draw the white mask on the top of the video, letting the circles show. So we have an arc here instead of, so if we use the arc instead of an XY coordinate and then fill it in with lines, then we're actually drawing a circle. And then the same move and check, and then the same load and unload, essentially, on the canvas. So maps. So we've seen video, we've seen audio, we've seen drawing. Maps are pretty easy. Maps is kind of bare bone basic. It's been around for a while. In fact, most people started using the maps first because it was kind of nice. Because most websites need some sort of mapping capability. Get directions, so put it in the website. Actually, a lot of people are pretty lazy. They'll just send you to Google Maps instead and fill in. Send you to Google Maps and send your address along with the location service captured address of the user. So you can use the Google Maps API to bring up a map at a current location and responds to clicking by placing a marker and calculating the distance, and it provides a way to change to fixed set or locations or the last marker. And need to give permissions to share the location because it relies upon your location information if you're going to do some sort of information oriented map application. Works in Chrome and Firefox, does not work in Safari or for Windows. Actually works in Safari for the Mac, but not for the Windows system. So Chrome is actually not a bad HTML5 browser to be using. Firefox is okay, but Chrome I'm finding is a little bit more compatible with HTML5. So, but that might supposed to be my own experience. So the opening screen kind of looks like this. And what they did in this example is you've got on the bottom here a little, and this is the example from the book as well, so all of these examples come from that book. So you can change the base location by clicking on one of these buttons down here, and one of them is going to be a, what does I say, Purchase College, Illinois Institute of Technology, and CUNY, another college. So you can change the location graphically, and the base location of the current geolocation is supposed to be here. And then turn on or off, deny or don't deny, allow or deny the location services, which is part of the browser. So your Chrome browser is going to support this. So you get a little notification that comes up in the status bar, right? Underneath on the top of the web page, underneath the main bar that says, enable this, allow this, don't allow that. You'll get one of those that comes up. And if the user says deny it, your map's not going to show. So there's no way to set that as a default, because then you'd be taking the control away from the user. So here's brings up the map at a starting location. We're going to set the geolocation, longitude and latitude location, just the same way as you do in other uses of the Google. In fact, this is just the Google API. Same way as it's being used in the Android or also in other platforms. So after they click on the map, well, it's going to zoom in. So here, nothing happened. We clicked on it, and now we're going to have this location here. This is where you clicked, kind of thing, or this is where we're going to go to a particular location. So after you choose, let's say for example, CUNY, it'll take you to CUNY location. After you choose one of the other options, it'll take you to one of the other option locations. So this is kind of like, if you ever seen those store, you go to, I don't know, like Target. Sometimes you click on the map of the state of California, and then underneath it says, all these different store locations, and you click on the store location, it brings up the map with the store location on it. This is kind of the same thing, and it's really easy to do, actually, to put it together. It looks sophisticated, though, but it's really easy, actually. So the Google API and other applications from Google actually works. So Google has many different APIs. Maps are important, but some of the audio and the video, audio applications for text-to-speech and for speech-to-text, which is kind of interesting. You can create, actually I had a student, not here, but at another school, recently actually showed me a pretty cool app that he built that is kind of like Siri, but it's a fake Siri. And it's using Google Play speech recognition. So you're talking about, you can say Robert or Bob, because it's no longer Siri, and you have to load the app up to do it. Find me the best restaurants in California or something. And it actually brings up Google Maps. It shows, this is why I remembered it, actually, because it came to mind when I started looking at this mapping stuff. And it does the Google Play speech to text. So it takes the speech, puts it into text, parses the text, maps it to locations does a search and finds, find me all the Target stores in this area. Finds, does a search, parses the information out, and actually maps it out to mimic what the other programs are doing. So you don't actually have to go in a web browser and type in the information. It's actually running a web search for you is what it's doing. But it's kind of similar to a Siri kind of application. It's actually really cool. So. But it's nice because it's sometimes, you don't want to, you're going to use the app, and say, call Luigi's, order spaghetti for me, or something, then it can go call Luigi's and order, to automate your tasks essentially for you. So I'm thinking that might actually be a cool app to kind of play around with. But I did another one actually on the Android phone that reads text messages for you. So, well, there's plenty of them out there, but it's also using the Google Play API. It's about 5 or 6 lines of code. And it says, read me my text. Or you actually don't do that. On my app, you just press a button. It says, read text. It says, new text from blah, 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 blah. Hello, how are you today? Blah, blah, blah. And it just reads you the text messages, so you don't have to.
In Android, I think for the navigation, normally give you an option whether you want to text or to speak.
Yeah, yeah, yeah. It does actually, but you can build the API into your apps, your own apps. Yeah, but so you don't have to actually press any options or do anything. So, which is kind of cool. Actually, you could just set it in auto mode. You know, I could create an app called it auto mode, and just do voice recognition on everything. Create your own Siri. You can say, Android, check my email for me. Do I have a new email? No. Okay. Thank you.
So lazy.
It's like, replacement for a human thinking, which is not bad, actually. Think about it. Isn't that what Siri's supposed to do? All right, so access, anyway, I just had a little thought that came out, a little tangent there. But so the Google Maps themselves, if we go back to maps here, defines the positions using latitude and longitude for the data object. And you access the Google Maps. It's created for a place in the HTML document using a specific map option. So we put the map in there. And then the HTML has a specification for doing the geolocation, which is the same thing we're doing when we do Android development actually as well. So navigation.geolocation produces longitude and latitude values, which is really cool. So how to get the positions? That's the hard part. On mobile devices, you have location services. Actually, on your newer operating systems, you also have location services. In fact, you have location services on Windows 8, which is really cool. And you have it on some of the Mountain Lion actually too. So you can get it. So to get the map from the browser location, you can do a JavaScript void prompt G application get map to get the center of the map, or click on a green beaker and enable the drop landing marker to come into it. So the right click on the normal click kind of thing. So in the sample program that's in the book here, it tries to use the geolocation. It gives the user options to pick the base location, and the user can click on the map and find the distance from the base center, and can change the base to the last clicked position, and the general access to Google Maps features is demonstrated in it. So in terms of the basic concept, it depends on the browser that you're using in terms of the navigation approach and how you're going to get the location. You can actually go online and set a base location, so which is what everybody does anyway. So you know your address, your target store, you know what the address is. You find the longitude and latitude by looking up the physical address. There's many different websites that allow you to do this. You set the location, longitude, and latitude as the starting position, so here's the store. And then you ask the user, what's your address? And you set the longitude, latitude of that location. Here you are. So then you have the red and the blue pin, and then you can draw the map. And easily, you're 5 minutes away, or 4 minutes away. So navigator.geolocation checks if the object exists, does not cause any errors or at all. If it doesn't exist, if there is a location, then get the current position, and then we have a problem handler if we can't get the current position, and the handler when things go okay, and problem handler when things are erroneous, when we have errors, and includes deciding not to share the location or something. If you have location sharing turned off, you're going to have a problem if you go to a website that's going to ask you for that. And the solution is there's an automatic browser control normally that pops up a little window that says, hey, this website wants your location. Do you want to share it? Yes or no? And then say no. And then you have to ask something else so your application can respond and say, hey, this mapping feature is not going to work because you refuse to share your location. Or something like that. Maybe something nicer that comes up. So creating and accessing the Google Maps, if we look at the code here, we have the map is going to be equal to. We have a map element, map variable, just like we have a canvas, now we have a map. Map is equal to a new Google Maps. For a place called get element by ID place, which is going to use my options that are going to be associated with it. So it brings up Google Map in the div with the ID place using the parameters in the my options that we're going to set. So here we have the div ID place, and in place with the style, the width and the height. So we use the the percent sign here with the width and the height. They don't work with document type HTML is being used. So some of the tags actually have specifics in terms of what document type, and so some of them don't work with the HTML document type because it's going to override the browser control. to kind of put that in. So styles and external scripts can also be used. And we have to, because we have this external script here for the Google Maps API that we need to put in here. So we have a style block at the top, style ending, we have a script block here. We're going to put in the example. So we're going to set the font size to this, we're going to display the block, and we're going to set here the script to the using the API JavaScript, Google API that's going to work with that. And then in the init method, we're going to initialize the navigation geolocation to the current position, run the methods to find it, and then also find the element, and then place the map where the element place is located in the div tag that we've created on the website. And then the function handler that is going to go and give us our longitude and latitude if we haven't, and then run the function make map with the longitude and the latitude that we have. And then we have the problem handler that says, hey, I'm just going to give out that nasty message, hey, you didn't give us our location, so we can't put the map out there for you. So tough luck kind of thing. And then we have the variables that we're going to use in this example, listener, because the user is going to click on the map, hopefully. The marker array, the battling, well, okay, so the options are going to be set, the locations. This is Memphis, Tennessee, actually, where purchase SUNY. The create and the access map here, the make map method, that's going to be functioned out. I'm not going to go through the methods, but if you take and download the example and go through the code, you can alter it to fix the locations and better understand the variables and what's being used with it. Click it, the function is going to be, we're going to put a mouse listener on there. So if someone clicks on the map, we're going to catch the event and then run click, click it event that's going to happen. And then the function distance, and with 2 points from point A and point B, and the point's going to be defined by longitude and latitude, and we're going to say, well, what's the distance between these 2 points? And it's going to say 5 miles or 10 miles, depending upon what we come back with. It's just taking the longitude and latitude of point A and point B and calculating the subtraction, the differences between them. So, and then the change base, we're just going to change the starting location or the ending location, depending upon what we're considering the base. And then we're going to take a look at the header here and go to the base location. That's going to be at the location that's going to be, and we're going to actually display the base location at the top of the map so we can kind of see where we're starting at. It's nice to tell the user actually where location you're starting at. So normally on the map you can put a little overlay on it that says, target store number 5, and here's the location. So sometimes actually those little overlays are kind of confusing because it'll put the longitude and latitude up there. It's like, what is the user going to do with that? So. See, this is the code for the radio buttons to switch locations, change the base location if you're going to change it to the different options, so we don't really have to. So a variation on this theme would be a geolocation that returns accuracy and maybe other information, including altitude or something, or maybe current temperature, or you can use another API to get temperature, weather conditions. This application marks the center with a mark with a red X and displays other information. You can actually change the image that appears on there as well. And note that the accuracy is given in meters in both cases. So depends on what kind of accuracy you're looking for. So you can use a custom image for the marker. That little pin symbol. It's just a PNG file. So X pin, Y pin. You can change your pins around if you wanted to. So here's the variable X marker. The marker is going to be equal to, well, whatever position is the center of the longitude, latitude kind of location that we're looking at. So and get the current position. Here's the third parameter. Add the output for the the C out for the output, which is C like C++ syntax actually to print out to the screen, to the document actually. So document C out. And then the next application here, which is persistent storage. So I didn't really go through the map stuff in that much detail because you're going to basically have to thumb through it to set the coordinates, set the longitude, latitude, the position, depending upon what it is you're trying to accomplish, set the images and stuff like that. So HTML5 also supports what's called persistent storage, aka cookies, but not using cookies. So the next application example is in terms of this. So the normal situation is there's no change in the client computer beyond downloading files. That's about all the computer does on the client side. Cookies were invented with a pleasing name, cookies. They're good, right? To be files associated with each browser to be used only by the same server site. So it was convenient, had IDs, passwords, preferences, behavioral marketing, all that kind of stuff. But then cookies got a bad name. So earlier HTML supported cookies. Local storage is a new variation of the cookie. So caution, Firefox requires the program to run on a server. Chrome allows running locally. So we can run the local storage services with some browsers. Acts like cookies, sounds like cookies, not a cookie. It's a HTML5 replacement for the cookie concept, not blocked by the browser, actually implemented as a feature of the browser, which is a slightly different approach. Firefox won't allow it though. It has to run on the cookie service has to run actually on the server, won't run from a local browser. Chrome though will support it, which is why I'm kind of recommending Chrome actually. So what are we going to do? We're going to save the base location. Save all of these locations. So the next example actually just saves the locations and puts it in, it creates an object for the local storage and it stores it in a text file. Just like a cookie actually. But it stores it on the server or on the client depending upon how you're going to design the program. Here's the base location is your current geolocation if you open it up. And then we have the new base that we can create. We put a little menu on the bottom here to go to the different locations. So the objective is to add to the Maps app 3 buttons. Store the base, retrieve the base, store, change the base to the last marker. So you're going to use the storage that's being saved for each one of the locations. And then the local storage used to name the value pairs. So the name value pairs are going to be used in a local storage concept. And do error checking, check for the ability to do the local storage, and it's called local storage is the object, and then check if there is a stored time, how long the storage is going to be kept for, so which is set by the browser. So we have 3 buttons invoking store, retrieve, and change base to marker, and we use a try and a catch to essentially see if we can get at this code. See if this object, excuse me, and the code is to try will not trigger an error. But if there is one, we can do a catch. So we'll go to catch. Also use a type of, which is a local storage, to test if that is defined. And then you know if the browser is going to support it or not. So here's our on-click event for our JavaScript store, retrieve, and change base to marker. So when we click the buttons, we're going to run these 3 different methods. And here are 3 different methods. The first one, I don't have to go through all of them. I'm just going to go through one here, the store. So if the type of local storage is equal to undefined, which means no browser support. Browser does not recognize HTML local storage. It's going to be printed to the screen. If not, then try it. And you're going to do a try and a catch on this, just the same way as you do file IO, because it's opening up something similar to a text file, not a text file. This is accepted by the browser, controlled by the browser. So you can't actually go in and look at it. Well, you probably could, but you're not going to. Local storage.set item, and you're going to set it to information. So this is going to be the base latitude, and this is going to be the variable. So it's going to be a number. So you have a key value lookup system. So you have this one's going to be latitude. It's going to be equal to 500. Longitude is going to be equal to 10,000 or something. And you have it's like a dictionary lookup. And it's not like a text file, it's more of a dictionary lookup. So we're going to store this variable with this value, this variable with this value. And we're going to do a catch on it. And the catch is going to do an alert here. It says error with the use of the local storage. Perhaps it's not available, perhaps it's filled up, or you have to give permission or something like that for it. Who knows what the error might be. To retrieve it, you're going to do basically the same concept as before. You're going to try to see if it's there. If it's not there, don't worry about it. Browser doesn't support it. Else, do local storage.get item. So we set item, get item on a local storage event. So old latitude is going to be local storage.get item. Local storage. We don't have to create an instance. We just call local storage. And local storage is an object that's available, kind of like document, of an HTML5 compatible browser. It's part of the object model. It's just an object that stores the local data. which is very similar to cookies actually. So change the base marker, and the code is pretty much the same. It's calling a set or a get on the item. So comments error checking is good. Using a try and a catch is good because otherwise we don't know if we're getting the information. So if we don't do that, then the map just doesn't show the correct address. Many geographical information systems programs with common similar features are out there. Actually, this is very popular actually in terms of its implementation. Need to determine where the information goes. So the My Locations array keeps information in the JavaScript that's being used for this program. So yet another, oh, I did put it in here. Here's the ISBN. Let's see if it works. The last but not least, a plug for the book. Another plug for the book. So site security certificate is not trusted. Well, let's proceed anyway. No, okay, forget it. So that URL is not going to work. Probably, let's see, this ISBN is probably good though, but the site apparently has got issues. But the ISBN should work here. Yeah, we'll see. I mean, you can look it up. Otherwise, you can probably find another book that's very similar to it in nature. What you're looking for is essentially, if you already know HTML, then just what are the new features of 5? That's what you want. And I just gave you a map of the new features of 5, so I shouldn't say map, an overview. So introduction applications, mainly familiar games are used with Hangman. There's a quiz game in there as well. That's pretty good. Critical requirements that are needed to support it. HTML5, CSS, and JavaScript features. Complete code with comments. Many chapters involve sets of applications. Well, introduction to JavaScript programming is in that book, but not, not so much. Not an encyclopedia. It's not an encyclopedia of features. Instead, it's just examples and stuff. So applications that are in this book, as mentioned before, there's a dice game in there. There's a bouncing ball, cannonball. I only went through and gave you a snapshot. There's more information, actually, more examples in that book. Quiz game, maze, rock, paper, scissors, a blackjack, actually, kind of card game that's in there as well. So you might find it interesting. It's totally up to you. You don't have to get the book. For this particular class, this is kind of, I just threw in this HTML lecture just to kind of give you, because somebody requested it actually. Trying to tell you, well, what's new in HTML? The same stuff. You just have a couple more tags, essentially, more capabilities. So let me end this video.